Please welcome Mr. Subhojit Bose.
Very good morning. It's really a great honor, and I am humbled to speak after Dr. Masalkar, a legend in chemical engineering. My dear delegates, friends, the students, again a very warm good morning to all of you. Well, let me tell a brief about myself. I was a student of this college in chemical engineering department from 1985 to 1989. And then after a brief stint in one company, I joined oil and gas industries, and I am working for more than 33 years in Oil and Natural Gas Corporation. So it's a long journey in a field which I now say is at the focus of everyone for some other reason. We are the producer of fossil fuel. Now, fossil fuel means it's doing a sort of a crime. We are polluting the very climate. And there is this a paradox. We are producer of the cheapest source of energy, and at the same time, we are destroying the climate. So my honest confession is, if there is a green activist here, he will first shoot me before I start giving this lecture. Carbon and oxygen, the two basic building blocks. Carbon is the basic building block of life. Oxygen is providing support to life. But when they meet together and when it is in excess, it creates havoc. Can I have my presentation, please? So my topic is future of oil and gas and chasing low carbon intensity barrel responsibly. Is there a low carbon intensity barrel? Barrels will produce same amount of carbon. So our job is to how to take out carbon from the atmosphere. So that is the challenge. World has been discussing since long about the future of fossil fuel. And in COP26 and COP27, the great concern was expressed, and at the same time, great expectations also. Now, working with this industry for a very long time, I can tell you one thing for sure, and that is confirmed that fossil fuel is not going to go away very soon. By all estimate, by all agencies, the fossil fuel will remain dominating the energy scenario till 2050 and beyond. Globally, the share of fossil fuels, globally I am telling, will be 77% in 2050. And even if the big push for the renewables, it will only occupy around 20%. And the rest nuclear, etc., will be the rest 3%. So sharing this data, what I am trying to say is that both the things are equally important now. We have to produce fossil fuel, and at the same time, the climatic concern will remain the prime. It must be always remembered that during the development of the industrial revolution, the basic factor was the fossil fuel. Oil and gas was the key in the industrial revolution, and it will continue to do so for many more years to come. Why? because of the three reasons. First, it is having an obvious cost advantage. Second, it is having the highest energy intensity. And third, it is reliable. The renewables still now have not come to meet or beat fossil fuels in this. The other factor which will continue for the fossil fuel is there is already a huge investment had been done in the oil and gas sector, and it has having a business repercussions. So, no matter how you take it, oil and gas sector will continue. Let us see that how the fossil fuel industry is standing now in respect of India. In India, we are having a huge dependence on imported fuel. At present, we are importing 83% of our oil requirement and around 45% of our natural gas requirement. And we are paying an import bill of $119 billion. If I convert it to rupees, it is more than 9,20,000 crore rupees per year. And if I see the future, that is now, FY22, the energy demand in India is anticipated to grow at the fastest pace in the world among all developing countries. Our primary energy demand will rise to 1,123 million tons of oil equivalent, nearly double as it is today by 2040, when our GDP will reach $8.6 trillion. By 2040, India will still be having dominated by the fossil fuels. The coal, gas, and oil will still continue to dominate around 62% of the market share. Some of the other mind-boggling numbers. Presently, we are using 4.9 million barrels per day. It will increase to 10 million barrels per day. In 2021, our total oil requirement was 201 million ton per annum. It will shoot up to 500 million ton per annum in 2040. Similarly, gas, which is presently, our consumption is around 174 million cubic meter per day, it will increase up to 550 million cubic meter per day by 2030. Net dependence of imported oil will be more than 90% in 2040. Gas import will be 4 times to 60%. An annual import bill will shoot up to almost 3 times. These are the very scary things, right? But this is the reality. So, oil and gas will continue to dominate the energy market. That means we have to produce more. Our government is telling that we have to improve the domestic production. This is one side of the story. So we cannot just look away from oil and gas and say that, no, these are dirty fuels and we cannot use it. But the most important thing is the climate concerns. The climate concern is, as you all know, that it produces carbon dioxide. And with the increased use of fossil fuels, we must remember that it should be consistent with the third pillar of sustainable development as defined by United Nations. That means protection of the environment. Let me come back to this slide and see that what a paradox. You have to produce and use more oil, and at the same time, you have to reduce the carbon dioxide emission by 3.4 billion gigaton of CO2 equivalent by 2040. The purpose, as defined in COP 26 and 27, we have to reduce the global warming by, we have to limit the global warming by 1.5 degrees Celsius, and we have to reduce greenhouse gas emission. So this is a continuous process. So year on year basis, our demand will increase, our CO2 liberation will increase, but the emission we have to reduce. That means we have to capture carbon dioxide. That means our barrels will have lesser carbon intensity. It should have a lesser CO2 footprint. Now, how much we are polluting? How much this fuel gas sector is polluting? Huge. We are directly and indirectly giving 42% of global greenhouse emission. It's a shame, isn't it? 9% is scenario 1 and scenario 2, scope 1 and scope 2 emission. That means that is internal to the industry. Scope 1 emission is because of some leakage. It is not directly carbon dioxide, it is other greenhouse gas like methane. Scope 2 is for your internal operation. Generate power. We generate power, we use gas, we use oil, and that is scope 2 emission. Scope 3 is beyond the scope of the industry. It is after the fuel goes to some other place and what they use. So scope 1 and scope 2 emissions are inside the operation, and 9% of this 42 is scope 1 and scope 2, and 33% is scope 3. Now, in this greenhouse gas emission, 30% is CO2 emission, and 62% is non-CO2. Now, this is interesting, and this is where, this particular area is where chemical engineering fraternity can do a lot in carbon dioxide mitigation. So, let us now see that what are the methods by which we can decarbonize. As I said, scope 1 and scope 2 are within industry's limit. And scope 3 is obviously how we can go to the renewables and all. Now, one of the method of obvious CO2 mitigation is carbon sequestration, natural method. Means you offset the emissions through natural carbon sinks, like oceans, plants, forest, and soil. As of now, it is around 2.4 billion tons of CO2 which is being consumed by the natural sequestering. Now, what we can do more? Obviously, more plantation. And how we can do? You can see that a global energy major, ENI, they have announced programs to plant 20 million acres of land in Africa to serve as a carbon sink. Similarly, in India, efforts are on the way to construct carbon sinks of 2.5 to 3 billion tons through afforestation by 2030. Now, Indian government aims to restore 26 million hectares of degraded land, which will lead to the carbon sequestration. So, industry is already engaged in this, and they are trying, because this is the easiest method, but this will not remove huge amount of carbon. That is also true. Now, what else? What industry can do? Industry can do a lot, and this is where I feel the chemical engineering can do a lot. A few minutes back, Dr. Mashalkar was telling this thing that we have to solve the problem as per the need. Improving energy efficiency, this is a need. Any industry does not run at the full efficiency. We don't take out, we don't do the energy optimization to the fullest. Obsolescence and redundancies should be removed. And new technologies, you recover your waste heat, you recover your energy. That will also give to lesser carbon footprint. Then electrification. Now, electrification is a very interesting subject. What is happening in the Europe and North Sea is, now their offshore plants they are now slowly reducing captive generation in offshore. They are supplying power from the land. Why? Because they are generating green power, and they are reducing net carbon footprint. India has a long, long way to go. We are still at the nascent stage. We are only generating around 174 gigawatt of solar power now. I went to Norway. They are 95% of their power is hydel. And it is so nice to see that now they are actually powering their remote offshore platforms through power from shore. The most interesting and the most challenging is the next one, CCUS, carbon capture, utilization, and storage. Now we have to capture carbon, then you have to take it somewhere and then put it back into the reservoir underground somewhere. The first CCUS plant is coming in Norway. It is a company called Northern Lights. They will store the carbon there, and then they will inject it into a saline aquifer in North Sea, not into the oil field. There are other programs that are going on for injecting the carbon into the oil reservoir to enhance oil recovery. But you'll be surprised, what is the cost of this carbon capture? It is $58 per ton. As ONGC is doing a joint venture with IOC, it is coming out to be $58 per ton. It is prohibitive. Nobody can sustain such a high cost. And to sustain this, oil price should be $150 a barrel, which is not possible. The economic will sink at $150 a barrel. So this is where the CCUS is very promising. And by 2030, overall, we'll be actually capturing around 200 million ton of carbon dioxide. But you know the number, how much carbon dioxide is being emitted per year? It is between 33 to 35 billion tons. So 33 to 35 billion tons, and we will be only capturing around 200 to 300 million tons. Long way to go. Now, obviously, if we use gas is a better fuel, cleaner fuel. Obviously, shifting to gas is better. Indian government has already announced that we will be utilizing 15% of the gas. Right now, we are using around 6% is our gas fuel. And that will be having, gas is having advantage. It is 40% less pollutant than coal and 20% lesser than oil. And obviously the biofuels, you all know it. Now these are the areas where, when I see the students at the back, these are the areas where you people are having tremendous opportunity to grow, to do research. We are talking about alternate fuels. I did not touch about the alternate fuels, yes. The change of fuel to green hydrogen, blue hydrogen, and ammonia. You all know it. Dr. Masalkar just now said. But the only thing is that price. Industry will change to anything when the cost will come down. Industry will change to CCUS when the cost will come down. Industry will change to hydrogen if the cost comes down. But it is still very prohibitive. It is still more than double the cost of conventional source of power. So we have to change, we have to research, we have to find out the solution for the industry. Another very interesting area is ammonia, production of green ammonia from the green power. Only one plant in the world in USA as of now. But everybody, including ONGC is now actually investing around 25,000 crore to have 5 gigawatt of solar power. And from the 5 gigawatt of solar power, we'll have green hydrogen also. And we'll also, in collaboration with another company, to make ammonia. Coming to the other part, coming to the non-CO2 related emission, this is an easier area to mitigate, but it is happening. It is happening in a big way, fugitive emissions. There is a leakage. Methane is a very dangerous greenhouse gas. It is more dangerous than carbon dioxide. And methane is escaping everywhere in all industries. And it is invisible. And it is very light. Now we have fugitive detection cameras. And you'll be surprised to see that when you have used it, you will see that many places where your gas detector cannot sense, you can see the gas actually evolving from your valve stem, from the flanges, from your compressor body, from the pump. This all can be mitigated with the use of technology. You can have double mechanical seal of pump, on pump. You can use dry gas seals in compressors, carbon packing ring sets on valve stems. So there are solutions, but we have to find it, and you have to understand really the criticality of these emissions. The other thing is the flaring. Now, flaring contributes to 8% of greenhouse gas emission. That is also a very big quantity. World actually flares 144 billion cubic meter. 144 billion cubic meter. India's total production of gas is around 60 billion cubic meter. Now, that much gas, if the carbon dioxide is generated from 144 billion cubic meter of gas, is 400 million tons. So, if we can stop flaring, and I believe that the industry knows, all the industry have a zero flaring project, but apart from the technical flaring, every industry flares a huge amount, so that non-routine flaring is to be stopped. It is a crime. It is a loss of your hydrocarbon, and you are liberating carbon dioxide. So what is to be done? It is only the reliability of your equipment. It has to work all the time. There should not be unnecessary trippings, and there are other methods. Conversion, see, here we say something called technical flaring. That means it is such a low pressure, you cannot use it. But there are technology available now. You can convert that methane to methanol. Now, methane to methanol is not a new concept. Methane to methanol is a very old concept. There are plants, there are big plants. But there are no small plants. Nobody had scaled down. What we do always, we have a pilot plant, and then we scale up and go to the industry. Industry has a problem. All the plants are big. You have to scale down and make a mini plant of 25 tons per day, of 50 tons per day. And I am proud to say that ONGC is starting a joint venture where we will utilize these methane gas to convert to methanol. Methanol has unlimited usage. You can convert to anything. So, my dear friends, oil and gas sector is significantly engaged towards the climatic commitment. And with every day, new technology is coming, and it is the role of the chemical engineers to actually get these things done. You do research, you come out with a solution for the industry. Now, challenges, as I already said, it is doable. It is doable, there is no doubt about it. But what is required is the technical, financial, and operational strength. Very fortunately, the oil industry has all, because of the very high oil price. They make astronomical profit. But what they don't have is that the thrust. Why the thrust is missing? Thrust is missing is only because that nobody is penalizing. Unless otherwise somebody penalizes you, you are not bound to do something which is cost intensive. So a prudence and diligence is the need of the hour. And what is the three main component? One is 3 C's: cost, commitment, and compliance. Cost is not on the industry side now. Cost is very prohibitive for all the mitigation measures, like I am saying, whether it is CCUS, whether it is green hydrogen, you have to pay a lot. So it has to be economically feasible. And then the commitment. The commitment is, see the paradox here, that this is balancing the mandate of increasing your oil production and then reducing your greenhouse gas emission. Very, very funny, actually, proposition to the industry. So they are pressed for both. Now, many of the companies many of the oil majors are heavily investing in renewables. They don't call themselves no more an oil company. They said we are energy company. Total has become Total Energy. There was a company called Statoil. To remove that guilt of oil from its name, Statoil has changed its name to Equinor. So these are the changes which industry is doing, but this commitment should be genuine, and commitment should have analyzed all the physical and transition risk. These risks are regulatory, market, investors, and stakeholders. So this scenario analysis to be done, and it requires understanding of the current and future value chains and of emissions. The next big challenge is the compliance. I have committed, but I may not comply. Now, government is coming up with new policies, and community expectations are changing. They are becoming more and more concerned, and rightly so. So we must analyze these policies and statutes comprehensively, and we must see that we are not going for any false solutions. Approach has to be candid. And progressing for the transition, industry must address true impacts on current and future infrastructure and operation. This has to be done, and industry is bound to do it. Now, a very interesting thing in the oil and gas sector, that is the challenge of human resources. This oil industry had flourished. It started in the 60s and 70s, and it flourished in the 80s and 90s, and now it is the time for the big crew change. All the experience and skill that was associated with this industry are leaving. So there is a huge skill gap. And 50%, and this is global, this is not Indian. Every company is facing this big crew change. We are losing very experienced skill set, and there is a skill gap of 15 to 20 years. The other problem which is having is that this industry is not attracting young professionals. So the skill refocus has to be done by the industry, and they have to make best use of existing resources while also factoring the new candidate attraction from emerging generation. We are making effort to make itself attractive to the younger engineers. So a huge opportunity lies ahead of you, the students, the research scholars, and even for the faculties. Now coming to I'm concluding shortly. So the latest catchword is the energy trilemma. Energy trilemma is three parts. One is energy equity. Energy equity means for a poor country like us, energy should be affordable to everybody. The second thing, which I am discussed so far, environmental sustainability. And third part is the energy security. Now, all these things should be ensured. Energy should be provided to everybody without harming the nature and being affordable to all. Now, this is where we all should work together, and this is where academia should actually come and have collaboration with the industry to make this energy trilemma really, really feasible. This energy transition is a process where oil and gas industry needs chemical and process engineering wisdom. Chemical engineering discipline has to shake hands with the industry. We need you. We need your wisdom. We need your research to make our industry cleaner, greener, and at the same time, we have to produce more and more barrels for the country and to make everybody's life more secure. Before I conclude, I have to reiterate the things which I have told so far. Fossil fuels are here to stay, and for many, many more decades. And climatic concerns necessitates greening of our pursuits and providing technological solution for low carbon intensity barrel. Concurrent tasks, but though tough and challenging, it is doable. And for our alumni and for our alma mater serving this industry since decades, task is pretty cut out. Thank you, everybody. Thank you for listening to me.